Welcome back. Let's talk about how we predict the products from a single replacement reaction. When we're predicting the product for a single replacement reaction, remember what we're doing is we're taking the element that's by itself and it's trading places with one of the elements that's in the compound. And it's going to swap places with the element of similar type. So if you have a metal, it's going to switch places with the metal or the hydrogen that is present in the compound, because metal form positive ions and other metals and hydrogen form positive ions. If you have a halogen, you are going to swap places with the halogen in the compound because those form negative ions when they're in compounds. And so you always have to make sure you're switching the same type of element. Once you've swapped them out, then you're going to double check that the charges are balanced or are matched for positive and negative charges and adjust with subscripts as necessary. And then of course you would balance the equation at the end. Let's take a look at 3 examples. First one, I have magnesium metal reacting with silver nitrate solution. So magnesium is a metal, and so it's going to take the place of the silver, which is the other metal. So these guys are going to swap places, and as a result, the silver ends up being on its own on the other side, and then the magnesium is going to be combined with the nitrate. Now, at this point, you must check your charges for things in the compound. Magnesium, if you look at the periodic table, forms a +2 charge. Nitrate, you know, is -1. So you're going to need to add a subscript for the 2 nitrates. And then you need to balance this equation because it's not balanced because of that nitrate. So we'll come in, we'll tack a 2 in front of the silver nitrate and a 2 in front of the silver. And there I have a completed single replacement reaction. 2 more. Okay, here I've got fluorine. Fluorine is a halogen, and so it's going to take the place of the halogen, of the chlorine. And so when I go to swap things out, I'm going to do chlorine, and then I'm going to say NaF. Now let's check charges. Sodium's +1, fluorine's -1. That's good, but you have to remember to be on the lookout for diatomic elements. This is your 7+1 club. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, plus hydrogen. When those are not combined with another element, so when they're by themselves, they get a subscript of 2. So now all you have to do is balance the equation, and you are set. And let's tack some state symbols in here. Aqueous and chlorine is probably going to be aqueous dissolved in the water. There it is. Last one. Here we have zinc reacting with HCl, which is hydrochloric acid. Zinc is a metal. Metals will take the place of other metals or of hydrogen. Since there's no other metal, it's going to take the place of the hydrogen. So I'm going to flop those 2. So the hydrogen ends up by itself, and the zinc ends up in the compound with the chlorine. Zinc's charge in compounds is +2, chlorine's is -1. So I'm going to need a subscript of a 2 on the chlorine. And hydrogen is one of those diatomics. So now that it's by itself, it needs a subscript of a 2. Hydrogen is going to be a gas, and this guy is going to be aqueous. And so all we have to do is balance our equation, and it's done. That's the process. Don't forget to check your subscripts. Make sure that you're getting your charges balanced, and also make sure that you have any diatomic elements with a subscript of 2 when they are not in a compound.